Hey guys, welcome back to another session. So in this session I will discuss with you 20 more questions of HMT, heat and mass transfer. So before starting session, let me tell you we have launched our test series for NLC. Right, we have other test series also for HSC, JEE, GATE and other. But let me talk to you about NLC test series. We have two test series for this, one for non-technical, separate one. So it is for all the branches. Another one is for technical. In the non-technical section, we are providing 65 tests and the price for this test is only 299 rupees. For technical section, we are providing 10 full length tests. The price for this test series is only 149 rupees. Link for both the test series is in the description. For your ease, I have put the link of the technical series in the first comment. Okay. So let's move on to the question. Right. Let's solve it. So I would recommend you take a pen and notebook and start solving with me. For calculation of heat transfer by natural convection from a horizontal cylinder, what is the characteristics length in Grassup number? So my dear, in case of horizontal cylinder, right, this would be characteristics length, right, L, and this is what my dear D. So in case of horizontal cylinder, D is equal to L. That means diameter is equal to length, characteristics length in Grassup number. But it is my dear vertical, then it should be my dear height of the cylinder is equal to characteristics length, that is LC. Therefore, the answer for this question will be what, my dear? Option A is the correct answer for this question. Question number 102. For a fluid having Prandtl number equal to unity, it is saying PR is equal to 1. How are the hydrodynamic boundary layer thickness and thermal boundary layer thickness related? So we know that PR is equal to delta by delta T power 3. What is delta here? That is hydrodynamic boundary layer thickness, right? It is also known as velocity boundary layer thickness, and delta T, that is thermal boundary layer thickness. So it is equal to 1. So we can say that delta by delta T. Therefore, delta is equal to delta T. So the answer for this question is option A is the correct answer for this question. One more thing I wanted to share with you. That is what, my dear? Prandtl number is equal to nu by alpha is equal to mu Cp by K. Right. So you need to also remember these formulas because I have seen these formulas also useful for solving questions. Right. Let's move to the question number 103. Natural convection heat transfer coefficient over surface of vertical pipe and vertical flat plate for same height and fluid are equal. What is or are the possible reasons for the same height, both vertical, same fluid flow pattern? Select the correct answer using the codes given below should be, right, given below. It is give below written, but it is not correct. I think this should be given below. So my dear, answer for this question, let me share with you. It is talking about natural convection, right? It is not depend on, my dear, same height. It is not depend on both vertical, right? It is not depend on that thing. It is dependent on, my dear, fluid and the flow of fluid, because it is talking about natural convection flow pattern, right? You can say that. Therefore 3 and 4 options are correct. So which option is correct according to us? That is option C is the correct answer, right, according to me. Okay, now guys, let's move on to the question number 104. Schmidt number is the ratio of which of the following? So my dear, there are lots of dimensionless number like Prandtl number, Schmidt number, Nusselt number, Rayleigh number, Reynolds number, Lewis number, right, Stanton number. Like the same we have Schmidt number. So what is the formula for Schmidt number? That is what, my dear? Nu division D. Nu is what, my dear? Kinematic viscosity. What is D here, my dear? Diffusion coefficient. Therefore option C is the correct answer for this question. But there is a relation, my dear. Let me share the relation. That is with Lewis number and Schmidt number and, my dear, Prandtl number, right? This relation is very, very important for us. It is an amazing relation, and everybody, those are studying heat and mass transfer, they must know this relation, right? So can you guess the relation, my dear? Okay, just let me ask you this question. I will ask you another question. This is another simple question I'll ask you, but let me tell you the answer of this question so that there will not be so many questions, my dear, so that it will not create any problem, right? So my dear, in case of Prandtl number is equal to Schmidt number by Lewis number. Schmidt, we have a spelling Lewis, Lewis, right? So Schmidt number by Lewis number is equal to Prandtl number. So I have shared another relation with you for the Prandtl number. Write down this relation also on your notebook. It will help you. Which non-dimensional number relates the thermal boundary layer and hydrodynamic boundary layer? So my dear, we know the answer for this question, right? It is talking about non-dimensional number. So here all the number we have given, all these numbers are non-dimensional, so there is no doubt in that. All right, but we know that the number related to thermal boundary layer and hydrodynamic boundary layer, that is what, delta by delta t power 3 is equal to what, my dear? Prandtl number. It is directly relating with this. Therefore answer for this question is what, my dear? Prandtl number. Option D is the correct answer for this question. Question number 106. Again guys, very simple question. If you are following any simple notes, you can get the answer of this question. Let me share with you. What is the, let me share the question first, then we'll talk on the answer of the question. What is hydraulic diameter used in place of diameter of for non-circular ducts equal to? So we have topic that is what, duct design. Generally we study this topic maybe in HMT, most of the time in case of convection, as well as sometimes we studied in RAC. But the answer for this question is what, my dear? There is a formula based question. So for A by M, what is A here? Area, and M is what? Perimeter. All right, so option B is the correct answer for this question. Question number 107, numerical problem, and that is good. Air at 20 degrees centigrade flows over a hot plate of 50 multiple 60 centimeter made of carbon steel maintained at 20 degrees centigrade. The convective heat transfer coefficient is 25 watt per meter square Kelvin. What will be heat loss from the plate? So my dear, we know that Q is equal to what? What is the formula for Q? Q is equal to HATS minus TF. So what is H here? 25. Area 0.5 multiple 0.6. Why we are writing 0.5, 0.6? Because it is given in centimeter. All the other things we have given in meter, and we have to find out in meter because it is talking about what watt. So watt itself is in SI. So you have to convert all the units in one unit system, that is what, SI for this case. So H is equal to 25, area 0.5 multiple 0.6, TS minus TF. TS is what we have given, my dear, surface temperature. So 220 minus TF is 220. Now do the calculation, and what is the answer? Let me share with you. That is what, my dear? 1500 watt. So answer for this question is what, my dear? Option A is the correct answer for this question. Question number 108. For a fluid flowing over a plate, flat plate, the Nusselt number at a point 0.5 meter from the leading edge is 100. If the thermal conductivity of the fluid is 0.025 watt per meter Kelvin, the coefficient of convective heat transfer is. So we have to find out coefficient of convective heat transfer. That means we have to find out H. So we know that Nusselt number Nu is equal to what? HL by K. We have given L is what? 0.5. We have to find out H. So H is equal to Nusselt number, that is 100, right? Multiple K, that is 0.025. Division what, my dear? L. L is what? 0.5. Do the calculation and tell the answer. What is the answer you are getting? That is what, my dear? 5 watt per meter square Kelvin. So answer for this question is what? Option B is the correct answer for this question. Question number 109. Good question. In a laminar flow over a flat plate, if you have studied about laminar flow, right, in convection properly, then you can answer of this question, because this is there is not like any big concept required to answer this question. So I want all of you, those are watching this session so far, please answer this question in the comment section if you can able to solve this question, and I am pretty sure if you can easily solve this question. But if you haven't studied about laminar flow over a flat plate, I will recommend you read that. It is very important, and then mark the correct answer. All right, so now let's move to question number 110. The laminar boundary layer occurs when a cold fluid flows over a hot plate. In which of the following positions the temperature gradient assumes zero value? What is temperature gradient? Basically dt by dx. It should be 0 when my temperature difference will be 0, and temperature difference will be 0 possible where, my dear? At the top of the boundary layer it is possible, right? Because as temperature equals to free stream of the temperature of the fluid, then only it will become 0. Therefore, my dear, answer for this question is what? Option C is the correct answer for this question. Let's move on to the question number 111. The Reynolds-Kohlberg analogy, which is used to determine heat transfer coefficient from the measurement of frictional drag, is applicable to. How it is applicable? We have to find out that. So we have given 4 options: circumferential fins, flat plates, rectangular fins, and triangular fins, right? So my dear, we can find out for this analogy we can find out types of fins we require. That is what, my dear? Inside pipe. You can find out inside pipe, but this option is not given in the answer, but we can also say that is what, my dear? Flat plate. So my dear, answer again it is given. Option B is the correct answer for this question. Question number 112. Hot air at 150 degrees centigrade flows over a flat plate maintained at 50 degrees centigrade. If the forced convection heat transfer coefficient is 75 watt per meter square Kelvin, the heat gain rate by the plate through an area of 2 meters square will be. What will be answer for this question? We have to find out. All right, so let's do some calculation. All right, so we know that Q is equal to what, my dear? HA multiple TS minus TF. So H is what, my dear? 75. A is what? 2. TS minus TF is what? 100. So do the calculation, right, and write the answer which option is correct according to you in the comment section. I hope you can do it, right? Write in the answer which option is correct according to, write in question number and answer in the comment section. Question number 113. Dimensionless quantity that connects the link between velocity flow field and temperature field is, my dear, directly if you will see the formulas for all these numbers, you will not find out answer of this question. But if you will see indirectly, that is what? Delta by delta T. Delta here is related to what? Velocity flow field, and delta T is related to what? Temperature field. Therefore answer for this question is what, my dear? Is to the power Prandtl number is equal to delta by delta T power 3, right? So answer for this question is what, my dear? Option B is the correct answer for this question. Question number 114. The characteristic length for computing Grashof number in case of horizontal cylinder is, my dear, we have done this. That is what? Diameter of the cylinder. So option B is the correct answer for this question. Question number 115. For which of these configuration is a minimum temperature difference required for natural convection to set in? My dear, for doing natural convection we require flat plate, right? So we can say that we can say that the plate required, that is in what, my dear? You can say the horizontal direction, right? So therefore option C is the correct answer for this question. If you understand the concept of what, my dear? Convection, then you can easily answer up this question, because it is like horizontal plate is required, right? Question number 116. Again it is talking about what, my dear? Prandtl number. Let's see what it is talking. For a fluid with Prandtl number PR is greater than 1, moment of boundary layer thickness decreases rapidly compared to the thermal boundary layer thickness, and thermal boundary layer thickness increases at the same rate, increases rapidly compared to thermal boundary thickness uske, and after then and thermal boundary layer thickness decreases at the same rate. So my dear, just look at the relation. PR is equal to what, my dear? Delta by delta T power what, my dear? 3. It is talking about PR is greater than 1. Therefore, delta should be greater than delta T. Otherwise, getting value greater than 1 is impossible because power is there. If you get values in decimal, it will become further less value, further decreases. Therefore, my dear, momentum boundary layer thickness, right, what will happen? Increases rapidly compared to thermal boundary layer thickness for this case. Therefore, option C is the correct answer for this question. Question number 117. The efficiency of a pin fin with insulated TP. So, formula based question they have asked. That is what, my dear? Option, my dear, 10 hypo. Let's see, right? 10 hypo ml by ml. What is L? Basically length, and M is what? Slope. Slope is equal to what? Root under HP by KA. How to remember? HP means Himachal Pradesh, KA means what? Karnataka. M is slope is equal to root under HP by KA. This is also an important formula. Therefore, answer for this question is what, my dear? Option B is the correct answer for this question. Question number 118. Again, once again, my dear, formula based question. Let me share with you. But this is a good question. This is a good question. If you understand about fin, if you have good concept about fin, then only you can solve this question. What is saying? Let's see. The insulated tip temperature of a rectangular horizontal fin having an excess over ambient root temperature of 0 degree centigrade. Not is 0 degree. It's theta naught is. So, my dear, for this, what we can say, we know that theta by theta naught is equal to cos hypo m L minus x. This relation we can write, right? Division cos hypo ml. For this case, L is equal to x. Therefore, this whole term will be 1. So, theta naught is equal to what, my dear? Theta naught is equal to that is, we will do cross multiplication, right? Let me do cross multiplication. We have to find out okay, we have to find out theta, right? So theta is equal to what, my dear? Theta naught division cos hypo ml. Therefore, my dear, option, which option is correct? If you will see, my dear, option D is the correct answer for this question. Question number 119. Again, guys, very good question. A fin surface consists of root or base area of 1 meter square and fin surface area of 2 meter square. The average heat transfer coefficient for the fin surface is 20 watt per meter square Kelvin. Effectiveness of fins provided is 0.75. If fin surface is with root or base temperature of 50 degrees centigrade is transferring heat to a fluid at 30 degrees centigrade, then rate of heat transfer is, we have to find out rate of heat transfer, that is, we have to find out Q. So Q is equal to, in case of fin, what we can write? HP Ka theta naught, we can write that. Alright. Now, my dear, we know another relation, that is what? Effectiveness is equal to what, my dear? That is Pk division what, my dear? Ka. Right. How we can remember Pk? Pk by Ka. Pk means what, my dear? Pinaki Krishna or Pinaki. Let's write KP, it will be better for me. Krishna Pradhan. Or Ka, what, my dear? Kundan Arora. Krishna Pradhan words Kundan Arora. Right. Now, my dear, look at this, the root, the whole root is there, right? So what we can write basically, let's see. We got what, my dear? Kp by Ha should be this is Ha, right? So what we got, my dear? Pk and both are same, both are in root under. So we'll send this term to this here. Epsilon multiple root under Ha, and Ha already given, we have given. So we can write basically epsilon multiple Ha multiple theta naught. What is theta naught, my dear? Temperature difference, right? What is epsilon? That is 0.75. H is what, my dear? 20. Area is 2 meter square, and the temperature difference is what, my dear? 20. So what we are getting exactly 300 watt. But one very good concept we have to look at here, that is what? We have given effectiveness is equal to 0.75, but remember my dear, we will not use fin if its effectiveness is less than even 2, right? Which is not effective for us. So we have to divide this term by 0.75. So if we'll do calculation, what we are getting, let me see. 400 what we are getting. Therefore option A is the correct answer for this question. Question number, last question for this session. In order to achieve maximum heat dissipation, the fin should be designed in such a way that, how we should design the fin for getting maximum heat dissipation, right? So my dear, see, this is another basic concept, my dear. It is only possible if suppose that we have hotted body here, we want to dissipate heat from here. So my dear, maximum area should be covered here, then only we can heat will transfer, and then we can dissipate heat to the environment or anywhere else where we want to, where we want to dissipate. So in that case, my dear, the case will consider where maximum area will be covered, that is root area, that is base area. So let's see, option A, what we have given, it should have maximum lateral surface at the root side of the fin. So my dear, it is saying that only. So option A is the correct answer for this question, because it is saying the perfect what I'm telling you, right? It is not talking about top, it is talking about, not talking about center, it is not talking about near the center. So my dear, option, my dear, A is the correct answer for this question. So guys, thank you very much for watching. Now guys, I told you earlier, NLC test series we have launched. We have launched 2 test series for non-technical as well as technical. For non-technical, we are providing 65 tests because most of the people struggle here, and for technical we are providing, my dear, 10 full length tests. For technical it is 149 rupees. For non-technical it is 299 rupees. And the link for both the test series is given in the first comment, in the description, and for the technical portion I have put in the first comment. Thank you very much for watching. Bye bye. See you soon. God bless you all. Like the video, share with your friends, and subscribe to the channel for updates. Bye bye.